Today we are going to look at key features on a graph. We've got probably the most common stuff, the x-axis and the y-axis. And then the origin is the point 0, 0. And then there are quadrants. They're in Roman numeral. So there's quadrant 1, and then we go counterclockwise all the way around. So quadrant 2, quadrant 3, and quadrant 4. They are called quads, like 4 of them. So those are our 4 quadrants. The next part says to plot the following points and determine what quadrant they are each in. So the point -1, 4, there's the point -1, 4. So I'll just put a 1 right there. Number 2 is the point 3, -9. So this is kind of off the chart here. We're already at -5 y value, -6, -7, -8. This would be my -9 y value. So 3, -9 is in quadrant 4, by the way. It's our second one. It's in quadrant 4. The point 16, again, kind of off the chart here. There's the point 16, our third point. It's in quadrant 1. And the point -2, -1. This is number 4 here. And it is in the third quadrant. Again, quadrant 1, 2, 3, and 4. So number 1 was in quadrant 2. Number 2 is in quadrant 4. And number 3 is in quadrant 1. Number 4 is in quadrant 3. All right, and then the last one isn't giving you a graph, and they're asking you which quadrant is the point -621, 309 in. And because there's a negative x value and a positive y value, it's got to be up here in quadrant 2. So I'm going to go with quadrant 2 on that one. All right, so we are going to look at a different kind of graph. We are going to look at a scatter plot. Scatter plot is a graph of plotted points that shows the relationship between 2 sets of data. So the table below shows the numbers n in thousands of cellular telecommunications service employees in the US from 2005 to 2014, where T represents the year. Sketch the scatter plot of the data below. So it's going to be a different kind of graph. My x's are like t and time. Instead of at 0, I'll probably start at 2005. And then we've got 2006, 2007, 2008, 9, 10, 11, 12, 13, and 14. And then the y-axis is actually going to be the n here. This is the number in thousands. So we are pretty much all in the 200s here. I'll probably go starting at 200,000 up to maybe like 210,000, 220,000, 230, 240, 250, 260, and I think the highest is not even over 270, so make that our highest there. And then let's plot these points. On 2005, we get 233.1. So a little between the 230 and the 240 is 233.1. In 2006, we had 253.8, a little over 250. And then 2007, we had 266.8. 2008 is 268.5, so pretty close to 270 here. 2009 is at 249.2, so almost 250. 2010 is at 250.4, so again, super close to 250, maybe a little higher, so I went up a little bit, but not by much. 2011 is at 238.1, so a little below 240. In 2012, we are at 230.1, so a little over 230. 2013 is a little over 230 as well, pretty dang close. 2014 is at 232.2, again, a little higher, but not by much. So because this is just a set of points, you can't see a line or curve that's connecting any of them. It's just the points. So this is our scatter plots. And the last thing we're going to look at is the Pythagorean theorem and the distance formula. They are so similar. I'm going to show you what I mean by that. The distance formula is basically doing Pythagorean theorem, but on your graph. You've got an x1, y1 point and an x2, y2 point. But you've got these points, and to find the distance of them, I'll show you if I square both sides of this distance formula, I get d squared equals x2 minus x1 all squared plus y2 minus y1 all squared. So this is kind of like my c squared. Subtracting my x values, it's kind of like my a, it's a squared. Subtracting my y values gives me like my b, and it's squared. So this is very similar to your Pythagorean theorem, just using a couple different xy points. So to find the distance between the points, I will use the distance formula. Here's my first point, so my first x and first y. On my second point, I have my second x and second y. So my distance equation is a big old square root of x2 minus x1. So 2 minus a negative 2. So like 2 plus 2 squared. Plus, now I need the y2, like my second y value, minus y1, my first y value. In this case, a 4 minus 1, and again, all squared. So I would say the most common mistake on this is the order of operations. I do need to do what's inside our parentheses first here. The 2 plus 2 is a 4, so I have a 4 squared. 4 minus 1 is 3, so I have 3 squared. Now I'm going to do my exponents. 4 squared is 16, and 3 squared is 9. Now I will do the 16 plus 9, which is 25, and the square root of 25 is 5. So the distance between these points is 5. All right, let's try this again. The distance is a big old square root, x2 minus x1. My second x, which in this case is 1, minus x1, my first x, which is a negative 3. Since I have to subtract negative 3, it turns into plus 3, and it's all squared. Plus y2 minus y1. So negative 2 minus 5, all squared. Again, order of operations. So I will do my parentheses. 1 plus 3 is 4, so I have a 4 squared. And the other parentheses, negative 2 minus 5 is a negative 7, and I will maintain parentheses on this. So be careful about that, especially the way you put it in your calculator. Make sure you use these parentheses. Order of operations, again, I am going to do my exponent. 4 squared is 16, and negative 7 squared is 49. Now I'm going to add up what's under the square root. So the square root of 65. And at this point, we don't know the exact square root of 65, so you might be able to do some simplifying. By that, I mean, let's break this down into 5 times 13. And I don't really know the square root of 5 or 13, so square root of 65 is what it's going to have to stay as. Okay, and then the last one here, show that the points 2, 1, 4, 0, and 5, 7 are vertices of a right triangle. So I'm going to look at this on a graph first. There's the point 2, 1, we've got the point 4, 0, and the point 5, 7. So 1, 2, 3, 4, 5, 6, 7. And they want us to prove that this is a right triangle. So I'm going to call them as A, B, and C, as you would for Pythagorean theorem. If the Pythagorean theorem works, then it has to be a right triangle. But I need to know what the sides are, and then I can see if it works on Pythagorean theorem. So I have to do the distance formula. If I do the distance formula between my first 2 points, that will give me my side A. So the distance of side A is, subtract my x values, so 4 minus 2 all squared plus 0 minus 1 all squared. 4 minus 2 is 2, so I get a 2 squared plus a negative 1 squared. 2 squared is 4, and negative 1 squared is a positive 1, so I get the square root of 5. For my side B is between these points, so in my distance formula, I get my x's subtracted plus my y's subtracted. So I end up with 3 squared plus 6 squared. So 9 plus 36 gives me a square root of 45. All right, now side C. Again, big old square root, that is going to go between these points here. So I will subtract my x's, 5 minus 4, plus subtract my y's, a 7 minus 0 is still 7 squared. All right, 5 minus 4 is 1. I've got a 1 squared plus 7 squared. 1 squared is still 1, and 7 squared is 49, so I get a square root of 50. Now, if this is a right triangle, then that means that the Pythagorean theorem is true. I already know what the A, B, and C is. That's what we just found out. So I will do my A, square root of 5, squared, plus B, which we found is square root of 45, squared, equals C, so square root of 50, squared. A square root squared, those totally undo each other. Square root squared, square root squared. So I end up with 5 plus 45 equals 50, which is true. So for that reason, yes, I can tell that it is a right triangle. All right, and our last type of question here is the midpoint formula. You're basically averaging out your x's and your y's. So it says find the midpoint of the line segment joining the points negative 5, negative 3, and 9, 3. I've got on my first point, I've got my first x and my first y. On the second point, I have my second x and second y. So in this formula, add up the x's and divide by 2. And then my y value will be adding up my y's and dividing by 2. So I'm going to do the numerators first. Negative 5 plus 9 is 4, so I have a 4 over 2. And negative 3 plus 3 is 0, so I end up with 0 over 2. So I end up with 4 over 2 and 0 over 2, which 4 divided by 2 is 2, and 0 divided by 2 is 0, so the point 2, 0 is the midpoint. It should be smack dab in the middle of these ones. All right, I hope that's helpful. Have a good day, guys.